Hello, Ignite. All right. My name is Edward Thomson. I'm a program manager for Azure DevOps. I focus on Git and version control. And today I'd like to kind of take you through some of my top tips for using Git. Real quick introduction. My name, again, Edward Thomson. I work right now as a program manager on the Azure DevOps team. Prior to becoming a program manager, I was actually an engineer. I worked on the Git implementation in Visual Studio Team Services, and then at GitHub. In my spare time, I like to unwind by writing a lot of code around Git repository management. So I'm the maintainer of an open source project called libgit2. Probably haven't heard of libgit2, and that's okay, we've heard of you. libgit2 is the underlying library that a lot of tools use for Git repository management. So a lot of GUI clients and then a lot of hosting providers like Azure Repos and GitHub, whenever you click merge pull request, that's actually libgit2 doing all the work. And you know, it's not all Git. No, actually it is. I also have a podcast about Git. It's called All Things Git. If you're interested in Git and version control, really software development in general, I'd encourage you to check it out. As you can kind of guess, I like Git, so feel free to hit me up if you want to talk about it. If you have questions, the best way to reach me is Twitter. I'm at eThompson. So again, I mentioned that I'm a program manager for Azure DevOps. If you don't know what that is, you could be forgiven. It's something that we just announced 2 weeks ago. Azure DevOps takes what was Visual Studio Team Services and evolves it into the next step. Azure DevOps is, so I hope that you saw Donovan Brown during the keynote. Donovan's definition of DevOps is it's the union of people, process, and products to enable continuous delivery of value to our customers. And that's what we believe at Microsoft. We think that you need the correct processes in place, the correct culture in place to do DevOps. And Azure DevOps is a set of tools that can help you achieve your DevOps transformation. So you start the planning of your software with Azure boards. That is Kanban boards and work item tracking. And the next step of that is actually writing the code and then getting it up to your other developers, to your peers that you collaborate with, and that's Azure Repos, which hosts your Git repositories. And then Azure Pipelines takes over, builds it, and puts it into production. So as you can guess, I focus mostly on Azure Repos. And so we're really excited about being able to break these individual components out so that you can adopt each of them as you see fit. So if you're using, say, Jira to manage your work items and GitHub to manage your source code, you can just use pipelines to do deployment. If you want just the Git repository management, you can use Azure Repos. And it's free for up to 5 users with unlimited private Git repositories. So that's something that we're very proud to be able to offer, all hosted in the Azure cloud. So how do you use this stuff, right? What are the tips for these for using Azure Repos? Well, we're going to start simple. Tip number 1, use pull requests. I hope that most of you all are doing it. Can I see a show of hands? How many people are using pull requests in your workflows? It's most of you, but it's not all of you. So I'm glad I did keep this as tip number 1. Either that or y'all are shy. Not sure which. Either way, there we go. So this is Azure DevOps. If you were using Visual Studio Team Services before, it looks pretty familiar, I hope. And it's hosting a really simple .NET app that I have created. And it's in a Git repository, and this is what the UI looks like for Azure DevOps. Now, if I want to actually work on some code, I can do that with my editor of choice. I like VS Code. I'm actually kind of old school Unixy, so I like VI as well, but we'll stick with Visual Studio Code for now. And I'm just going to make a little change. Maybe I want to title case this header up here, real straightforward. Just change the title casing, there we go. So now I could either use the Git functionality built into Visual Studio Code, or I can use the command line. add that file, commit it. And now, instead of pushing directly to master, which I could do, I could just run git push origin master, and now my code is available for everybody. What I actually want to do is push it up into a different branch. And in reality, the top tip would have been start with a different branch before you do the commit, but I'm really sloppy about that. I always forget. How can you get out of this situation if you do the same thing? What is there to do? My change is in my local master branch. Do I have to unwind everything? Do I have to redo it? No, actually, you can. Let me enlarge this a little bit. Instead of pushing git push origin master, this will push into the remote master branch. I can git push origin master : readme. And what this will do is it will take the contents of my master branch, since I was so sloppy as to commit to it locally, and it will create a remote branch on the server called readme. It won't touch the master branch on the server, so I can now create a pull request from readme into master. And actually, maybe I should give it a unique name. Let's call it readme demo. There we go. Obviously, I forgot to delete a few branches from my practice run. Whoops. So now, if I pop back over to Azure DevOps and hit reload, you can see, let me zoom in, that it actually knows that I pushed a new branch called readme demo, and it will prompt me to create a pull request. So Azure DevOps will suggest this best practice to you of using pull requests, because we really do think this is a best practice within the Azure DevOps team. So I can just hit create pull request, and now my coworkers can come and they can leave comments, they can collaborate, and they can approve it. If I pop over to pull requests, you can see that I actually already have one that one of my coworkers has created. Alice has made some changes. If I click on the commits tab, I can actually review each commit individually, and I can see what she's done. I think that's great. And so either I can merge this pull request for her. I can actually just click the complete button, and it will actually merge the code into master for her. Or what I recommend is I can click approve. What we suggest on the Azure DevOps team is to give everybody empower everybody to merge their own pull requests. Because we believe that you own a feature. You write the code, you merge it, and now you're responsible for it in production. So we actually don't merge each other's pull requests. We approve the pull requests. We indicate that we've reviewed the contents, and we like it, and we've signed off on it. Okay? So very straightforward. I know this is something that a lot of people are already doing. So, but we do suggest that you use it because it provides visibility into those changes, and it allows for everybody to make sure that they know what's going on in the code review process. So instead of trying to look at the history of what's in master, you can see what's coming before it lands. So best practice for us. Tip number 2, branch policies. So I said that pull requests are something that we rely on within the Azure DevOps team and something that we always use within the Azure DevOps team. You can actually make sure that that's true, that everybody is always using pull requests by turning on branch policies. And you can enforce a lot of different branch policies. It's not necessarily just pull requests. You can enforce CI/CD validation. You can enforce work item linking. Whatever the processes are, the best practices are that you use on your team, you can enforce with branch policies. So let's take a look at that. So if I click on the branches tab, I get a list of all the branches that are currently on my account, including that README branch that I forgot to delete earlier. Whoops. But the one I'm interested in is my master branch. That's my main integration branch. We use and suggest a trunk-based branching strategy. We don't suggest you make some complicated multi-branch setup where you've got maybe a dev and a master and you're trying to flow code between them. That's sometimes called git flow. We do not suggest that. We instead suggest that you have a master and you create simple topic branches that you pull request into the master branch. So it's my master branch that I'm interested in enforcing the policies on. I click this little ellipses right here for more actions, and then I can come down to branch policies. Right, so like I said, there are a number of branch policies that you can enforce. And as soon as you turn one of these on, now you must use pull requests to enforce these branch policies. The first one is that you can require a minimum number of reviewers. So when I open a pull request, now there is a requirement that somebody look at this code and click the approve button that you saw me do earlier before the person who authored it, or really anybody, can merge this pull request into master. You can set minimum number of reviewers as 1 if you'd like, and then you can select allow users to approve their own changes. Why on earth would you do this? Doesn't that defeat the whole purpose, right? So now I can open a pull request, I can approve my pull request, then I can complete my pull request, which feels like it goes outside the goal of this branch policy, but it does not. So what it does is it will enforce that you must use a pull request. So you do have that visibility, you have that traceability, and then you can see that I, or whomever, opened this pull request and merged it myself, approved it myself. But that can be very important, especially on a small team. If you've got an outage, and you need to get a hotfix into production, this is a good way to solve that problem. So you still get the visibility, but you also get the ability to deploy at 2 a.m. without having to wake somebody up to approve it. Okay? Another handy feature is to check for linked work items. This is something we use within the Azure DevOps team. We want the traceability back from the code to the work item. So why did this code come into production? Was it a bug? Is it fixing a bug? Is it adding a new feature? You get that traceability. And so this will make sure that you've linked something to a work item in Azure boards. I'll leave that off for now. You can also check for comment resolution. If somebody leaves a comment on a pull request that it has actually been resolved, you can enforce a merge strategy. This is obviously a little contentious sometimes. I'm not going to get into merge versus rebase. It's a holy war. It's not a top tip. And so I'm going to stay out of that. So I'll just leave that box unchecked. But the other cool stuff is that you can enforce build validation. So we'll take a look at build pipelines and how you can use them for pull requests in a minute. So for now, we'll just leave this as it is. We'll require a minimum number of reviewers at 1. And so really, all this does is it now protects the master branch from being pushed to, which is especially useful for me since I always forget to create a topic branch and I always end up doing this silly git push origin master : readme demo. So now if I change readme again, and maybe I add some exclamation points, this is a very exciting readme. And you noticed I did actually use VI. It's just muscle memory, I'm sorry. So if I run git add readme, git commit, and git push origin master. Oh, and if we zoom in a little bit, we actually get an error message. Pushes to this branch are not permitted. You must use a pull request to update the branch. So I think branch policies are a great way to take a look at the best practices that you have on your team that you've agreed with your teammates about and enforces them. So, like I said, we can also enforce build validation, and this I think is crucial. I would hope that it's a best practice on your team that the code in master is always compilable. I've worked on teams where that wasn't the case, and that is a bummer. You end up chasing people down to buy you donuts the next morning because they broke the build and then walked out the door. It's Friday, I'm in my car, I'm on my way home, and they get a phone call from me like, what did you do? You broke my build. It's no good. This is how you avoid buying people donuts or being owed donuts. You can add a build pipeline very easily. So this is Azure Pipelines. And it's very straightforward. It integrates with GitHub. It integrates with Azure repos. It really integrates with anybody if you click the visual designer. And it's very straightforward. I can select the repository I want to build, click Continue, and then I can just search for the type of build that I want to perform. This happens to be .NET Framework. Sorry, it's a .NET Desktop app. Click Apply. It will go ahead and set up the steps to do the build. And I can click Save and Queue. That's no problem. So that'll kick off my first build. But more importantly, I can come back to my repository, come back to the branch, click on the ellipsis, and go to branch policies. And now I can scroll down and add a build validation policy. So this will require that this build pipeline runs. I always keep this as required, by the way. You could make it optional. But this will require that the build pipeline runs so my build succeeds and all my tests pass before anybody can actually complete the pull request. So I always have a high confidence that my code is compiling. So if I actually break that, again, sorry, VI, just a bad habit that I need to get out of. What can we do here? I don't know. Let's just delete that. That code won't compile. And again, I can't push to master, so I will create a new branch on the server, pop back, go to my Files tab, create a pull request. It is indeed a bad pull request. And when I do that, you'll notice that I have these branch policies here. So 0 out of 1 reviewers have approved, so I can't actually complete this pull request, and the build is queued. If I try to click approve, that's fine. Now 1 reviewer has approved. That's great. I'm that 1 approver. Remember, I can merge with only 1 approver, and it can be me, but I can't complete the pull request. If I try to do it, it tells me that the build is, in fact, merely queued. I could auto-complete it so that when the build finishes and all the tests pass, that it will go ahead and merge it into the master branch. But until then, I am out of luck. Okay? So let's come back. I don't want to sit and wait for that build to complete. So pull requests are an incredible way to empower your team to do code reviews, but the disadvantage of pull requests is that it's all in the browser. Here's something I like to do periodically, and that's check out pull requests locally. So the nice thing about this then is that instead of just trying to intuit what some code is doing by staring at it in a browser, and especially some refactoring that goes over multiple different files, it can really be hard for me, at least, to get my head around, to make a mental model of the changes. And so instead of actually doing the review in the browser alone, you can download the pull request locally. And so then you can, I don't know, you can read it in your favorite text editor. You could even set a breakpoint in the debugger. You could step through and understand what some tricky bit of code is doing. It prevents you from going back on a pull request and saying, I don't understand what this is doing, which is a perfectly valid comment, of course. But it allows you to arm yourself with that knowledge instead of, especially what can be a long back and forth if the person maybe has gone home for the day. You know, maybe you want to do that code review now. So apologize for this. This is Git at its most terse and Unixy. All you have to do is run one of these two commands. For GitHub, it's the top one. For Azure repos, it's the bottom one. Just Google this, please. Just Google check out pull requests locally. There's a blog post for GitHub. There's a blog post for Azure repos. Don't try to memorize this, obviously. How could you possibly? But if you want some insight into what this is doing, it is adding a new fetch ref spec. Boy, I apologize even saying this. It adds a new fetch ref spec to your origin, to your remote called origin. And so the left-hand side, the side in green, apologies for anybody who's colorblind, the left-hand side, refs pull star head. So this is a secret branch that gets created on GitHub when you open a pull request. It's not something that you ever get when you clone a repository or fetch a repository. A ref is a branch or a tag. So they've made this sneaky namespace that Git ignores. And we've done the same thing with Azure repos. Ours is different, though. It's refs pull star merge. But by explicitly adding this ref spec, your Git client will now ask the server for it. And then it'll download those branches and put them into a special location on your computer, refs remotes origin PR star. Please don't try to remember this stuff. This is crazy. But what it allows you to do is then it will create a branch for each pull request with the pull request ID as the actual branch name. So let's take a look at that. And again, I'm going to type it in, but really, please, just copy and paste this stuff. So here in my repository, if I run git fetch, I do see a new branch that was created on the remote. But especially if you're using forks in your environment, you will. Those are completely separate. Those are completely outside of the scope of the repository for security. So I can git config --add remote.origin.fetch plus refs pull star. Nope, I'm not doing this. I'm Googling it. And there we go. Sure to find it. Hey, look at that. It's the top hit. Who knew? There it is right there. So yeah, so this is actually just my webpage. You really will find it if you don't include my name. I just would feel really embarrassed if it didn't work on stage. So let's run that command that handsome guy told me to run. Oh, sorry. Need a quote. Need to update that blog post. I also need to stop calling it Visual Studio Team Services. So there'll be a new blog post forthcoming. So seriously, just Google this. And now when I run git fetch, you can see I've got all these branches like origin, PR1, PR2, PR3, PR4, PR5, and I can check out PR3, and that was my coworker Alice's change. And I can show the changes, right, and see exactly what went on. So that's really handy if I want to go into VS Code and actually see her changes. She added this little bit of documentation right here. Probably not worth me going to the trouble of actually downloading this pull request locally and taking a look at it. But again, it's really handy to be able to set breakpoints, to be able to step through in the debugger and actually see what's going on. And again, you only have to set this configuration value one time. After that, subsequent pull requests, I can go ahead and download locally. So if I wanted to pop over, go to my files, go to my README, edit this, and commit it to a new branch, create a pull request into master. Great. Click create. Now this is PR number 6. You can see that up here in the kind of middle top. Now if I pop back to my terminal, run git fetch, now I can switch to PR6. And you can see that change that I just made. Cool. So again, this is something I do actually pretty regularly. Again, I maintain an open source project. It's written in C. I want to be able to step through that code. Okay, great. So, as nice as it is to be able to do code reviews with pull requests, to be able to review code in my browser and have a discussion, make comments on an individual line that I think might be troublesome. And as nice as it is to be able to download pull requests locally so that I can actually get a good mental model of the code as it is changing, I don't really trust either of those things. I'm human. I am totally human. I create bugs when I write code, and I miss bugs when I do code reviews. And I can give you a concrete example of that. This is an actual code review in an actual open source project that I actually, well, don't actually, I try to, as best as possible, maintain. And you might notice in the middle, there's a problem. The line ODB equals get compare and swap. The line below that tests is ODB equal, nope, no it doesn't, it totally doesn't. Whomever did this refactoring missed that and set ODB equal to null. Whoops. Obviously that was not what was intended. And we should have caught this in the code review, and we didn't catch it in the code review. We caught it when it was deployed in production and started crashing. So that's not good. But I feel bad about it, but I don't feel too bad because this was a big change. This was part of a big refactoring that we did that changed a lot of files, it touched a lot of code, and we missed it. It turns out that it's a lot easier when you are reviewing code to look at very small changes. And then you can catch problems like the one I just pointed out. It was really obvious, when you only saw 6 lines of context. When all of this stuff changes, when there's new tests added, when there's refactoring especially, people tend to look at the architectural changes. You look at things like, look at things like variable names quite often because naming is hard in computer science. And you look at things like the structure of the code. When you're changing thousands of lines, you very often miss subtle changes. And some people do crazy things like switch the condition around. So it would have said if null equal ODB. And that you would have caught that, but God, that's ugly. Please don't do that. That's not a top tip either. Don't do that. Instead, build this into your pipeline. We just set up a build pipeline to build and test our pull requests using Azure pipelines. Leverage other tools beyond that into your pipeline. So there are 2 great ones that I will just recommend immediately. One is SonarQube, in particular Sonar Cloud. They have a cloud-hosted offering, so you don't have to install anything. And the other one is WhiteSource, so, who again has a cloud offering. So no need to install a thing. SonarQube and Sonar Cloud do static code analysis. That would have caught my if ODB equals null error in the pull request process. And so now we have added a lot of static code analysis to libgit2 after an error like this occurred. WhiteSource is not strictly static code analysis. It actually does some security validation. So you can add security validation into the pull request process. So WhiteSource does something really clever. It will look at all the open source dependencies that you have. And I think most of us by this point have open source dependencies. I hope you haven't rolled your own logging framework. I have, don't do it. I work at Microsoft. We build everything. The nice thing about white source is, yeah, it will look at your open source dependencies and it will compare them against a database of CVEs. A CVE is a common vulnerability and exposure. It's the fancy name for a security hole. When you have a problem in your project, a security hole in your project, you go and get a CVE number from an organization called MITRE. And then you report the versions that are affected by this security vulnerability and the versions that have mitigated it. So white source can take this database and look at your code. It can inspect your code. It can look at your, I don't know, NuGet dependencies or whatever type of technology you're running. Maybe you're building a Java project. And it can analyze those dependencies to see if any of them are vulnerable. And it can do this, it will build a graph because those open source projects also have dependencies that might be vulnerable. So you don't have to do this because, what are you going to do? Hang out on every mailing list for every project you use? Are you going to hang out on every GitHub repository for every project you use, waiting to see a security announcement? Okay, you're probably going to miss all of the dependencies that they include, right? Humans are not good at walking graphs. Computers are really good at it. So let the computer do the work for you. The nice thing about both Sonar Cloud and white source is that it's just incredibly easy to just drop them right in to your build pipeline because they have extensions in the Azure DevOps marketplace. So actually, I have another build right somewhere. Right, here we go. So just like before, I want to create a new build pipeline. This time, I'm actually going to use a GitHub repository. It's that one. Click Continue. And again, this is a .NET Desktop app. That's the one right on top. I'll click Apply. And great. Now I have a build pipeline. Let me go ahead and save that real quick. Cool. So now I have a build pipeline. This is basically the same one we built earlier. All it does is do a NuGet restore, builds the solution, runs my tests, does some publishing of artifacts back up. But what I want to do is add a new stage, add a new task, rather. And that's that button right here. And I can search for Sonar Cloud. And I can actually add each of these steps individually. The nice thing, I think, about Sonar Cloud is I can actually, let me create yet another new pipeline. Use the visual designer again, and again, same repository, click Continue. And instead of clicking .NET Desktop app this time, Sonar Cloud actually has a bunch of pre-configured setups so that I don't have to add each of those steps. I can just add it once. I could do a .NET Desktop with Sonar Cloud. So they've taken the templates and gone ahead and added their integration. And that's true for other stuff too. Gradle, Maven, it isn't just .NET. So let me click Apply. I want to build on my hosted agents. And I've already set up a Sonar Cloud service endpoint. It's this one right here. That's wonderful. Click Refresh. And it should load there we go, it loads my organization. So I've already set up a Sonar Cloud account. I didn't want to bore you with those details. It was pretty quick, but still, right. What I didn't do, of course, is write down my project key. So let's pop over and look at the one I did earlier and edit it, steal its project key. This is actually something that you get off the Sonar Cloud website. Right. There we go. Should have been able to remember that. It's the same as my service endpoint. Right, and so now I am ready to go. So I'll save that one. Let me just make sure that that's got all the necessary bits. Indeed it does. Great. And so now I can put this as part of my build pipeline. So let me actually go ahead and queue a build here. because that'll take a couple minutes to actually do the build. And while that's running, let me add the next step, which is security scanning. So I don't just want static code analysis, I want the security scanning from white source. That is super simple too. Again, I just click that to add a task. And I can search for white source. If you haven't installed these yet, they show up down here in the marketplace, and you can just click add. I've installed them, so they show up instead in installed. So I'll click add there. And I also need to just set up my, there we go, set up my endpoint. And this one is Ignite Demo 5. Great. And I can save and queue that job as well. So let's take a look at the builds that are in progress here. Whoops. It's always fun when you screw something up on stage. Huh. OK. Well, obviously, I selected the wrong one. Thankfully, through the magic of television, this one did work. So we went ahead and set that up. Let's take a look at what this looks like generally when you get it right instead of screwing it up on stage. What you see is you prepare some analysis with Sonar Cloud. This just sets up, it integrates Sonar Cloud into the build. You do the build, of course, and then you run the code analysis step. So this uploads the information about my static code analysis to the cloud. And then it will run white source as well, where it will instrument my dependencies and upload that information to the cloud. And so what you get out of that is something that looks like this. So here is Sonar Cloud. And hey, look, I don't have any bugs. Wow, what a great project I wrote. I'm really impressed with myself. But what I do have is some technical debt and some code smells. So I was really amazed. I was expecting to have 0 bugs, because this is like a really straightforward demo application that, this is not something that I actually use really in production. But what I didn't expect was to have any code smells. So you can dig in on this. And it gives you like really excellent actionable feedback. Some things like stream should be read-only. There's simply no reason for this not to not be immutable. I have a return type that's never been used. And so this sort of static code analysis is really effective at finding problems. Even the code smells are actually actionable and worthwhile changes that I should be making. But when it starts finding bugs like the wrong kind of comparison, or an assignment rather, instead of a comparison, that's when you really start to see the value of this. And the same is true for white source. So here's an example of white source actually going through and finding vulnerable libraries. So here we go. Oh, looky there. I'm using an old version of struts. That's pretty bad. If you're familiar with the Equifax leak, so what happened was when there was a vulnerable version of struts, the Apache struts framework, so here's another reason not to write Java. The Apache struts framework had a vulnerability that was incredibly serious. And it was really obvious who's running struts because it reports itself in a header. So attackers would just blow through the internet, hitting every port 80 everywhere, and looking for a header that said that it was running a version of Apache struts that had this CVE. And they found it at Equifax, and that's why yours and my credit information is in the hands of attackers. And it doesn't take long, right? These security vulnerabilities are announced, and you've got to patch them quickly. So by adding white source into your continuous integration builds and then running it nightly, you can catch things like that before an attacker does. So I think this is incredibly important. This is something, these are tools that we use within Microsoft, within the Azure DevOps team. Okay. So We've talked a little bit about source code and keeping it safe, keeping it secure, but what about things that aren't source code? It turns out that a lot of people end up with code that needs to call something else. Maybe, let me give you a concrete example. I started using a new web page, some new web app the other day, and the first thing it did was load a video explaining to me how to use that web app. And that's very neat. I bet money that movie is versioned alongside the code. It's checked into a Git repository because you want to have the changes to that movie aligned with the changes to the code. When you change a widget, you want to update the movie to reflect that new look and feel. And it turns out that Git is not ideal at handling large files like movies. It was built to manage source code. And there's a couple of reasons for that, but the big one is that it's a distributed version control system, and it stores every copy of every file that ever gets checked into it. Okay? So if you have some commit, and you make a new commit, and you make a new commit, and you make yet another commit, you've got all of these commits when you run git clone. That's why it's called clone, because you get a complete copy of the other repository. And that's great for code because I can run git log and see my old code. I can run git diff and see how a file has changed over time, and I don't have to hit the server to do it. Remember TFVC when you would run these commands and you would wait. And if you were offline for some reason, or your VPN was down or whatever, then you'd wait until it timed out. That's no good. So Git is incredible and revolutionary, and I think a lot of us who use it every day have forgotten that to be true. But the people who try to check in binaries haven't forgotten. That ain't working for them because they've got every copy of every binary that they've ever checked in. So if you're checking in large corpuses of test data or movies, again, or images, you've got every copy that you've ever checked in, and that gets really bloaty really quickly. When you run git clone and it takes, I don't know, minutes when the contents of the most recent version are very small, then that's very, very frustrating. A lot of people propose what's called a shallow clone, or clone with the -- depth flag, so that you get a minimal amount of the history, and that will kind of alleviate this problem, but it's got side effects, and we'll see that in a minute. What we really want to do is we want to get these binaries out of our source tree, but we still want to manage them alongside the code. It's still nice to know the test data that corresponds to the actual version, the movies that correspond to the actual version. And so you can use a tool called Git LFS. Git LFS stands for Large File Support. And what it does is it takes these large files out of the repository and replaces them with an LFS file. It's a little pointer file that contains information about where to get the actual binary. So the actual large file is not inside the repository. It's hanging out somewhere else. For Azure repos, we store them in, surprise, Azure Blob Store, not in the Git repository. And so what you actually get when you run git clone is this little tiny pointer file. I mean, this is, bytes. This is tiny. And you can see that one of the fields, the last field, is size. So this was a pretty large file that we've replaced with a text file. And Git LFS will now integrate with Git to page this file in on demand. Let's take a look at how that works. Great. Okay, let's resize this a little bit. Okay, so I'm going to, I've got a large repository. I've got a repository that has checked in about 1,000 1 megabyte pings over the course of its history, but What's actually in the most recent commit in head is very small. I've only got 10 of these 1 megabyte pings. Unfortunately, yeah, I've got this so much history. When I run clone, it's going to take a minute. You can see it's receiving objects, 2%, 3%. Actually, the internet here is pretty good. I'm surprised. When on earth is conference Wi-Fi any good? But no, it's solid today. But still, we're at 8%, 9%. This is going to take a while, so I'm gonna go ahead and cancel that. Because I've also got the same repository, at least with the same structure, the same files at every revision, checked in with LFS. And so that's in a different repository. It's called largefiles-LFS. And when I clone that, you should be able to see the difference. Receiving objects, that was what we were stuck on before, is now at 100%. And oh, we're done. So that's a huge difference in the amount of time it took to clone everything down. It's also a huge difference in the amount of storage space that is taken up right now with this repository on my local machine and in the .git directory that has all my history. Let me go into that. If I run dir, you can see that I do just have 10 PNGs. And I can work with these. Each one's about a megabyte, except this one here that's image 05. What's in there? Oh, hey, it's the Git logo. Yay. It's a red Git logo on a blue background. And the reason I mention that, actually, let's shrink that down so that we can keep that up on the screen. Somehow, there we go. There we go. So the version of this file in head, I have no idea why I can't drag this. There we go. Is a red Git logo on a blue background. Now, so like I said, you could get this same effect by running git clone -- depth equals 1. It's called a shallow clone. Instead of getting all of the history of the repository, you only get the most recent commit and all the files that are included in it. But that is, I don't know, I think that is annoying. Here's why I think that's annoying. If I had done that, I couldn't run git log. Because, again, I've only got the most recent commit. I don't get any other information. If I run git log, it appears as if the most recent commit is the only commit that's ever existed. I can't run git blame on any files. Not just the binaries, on any files at all, because I don't have any of the repository information. I can't run git diff on anything, because they just don't exist locally. And most importantly, I can't switch branches or go to a previous version of my content. But with git LFS, I can. So I can check out this old branch right here. It's called old branch. I'm not real creative at naming. And when I check that out, you can see that this line says filtering content. It's the same thing that we had earlier. Git LFS interacts with Git as what's called a filter. And so it's invoked Git LFS to get the old data, and I've got all my files. And if I open image05.ping, which was, again, the red Git logo, the orangey red Git logo on a blue background, if I open it now in this old branch, it's the blue. It's the Git logo only in blue, but still on a blue background. So I think a top tip, if you're working with large files, do not try to shallow clone, and certainly don't clone it all down at once. Use Git LFS. If you have already started working with large files within Git, that's okay. There's a wonderful tool called the BFG repo cleaner. There's actually two ways that you can fix this problem. One is by running a crazy command called git filter branch, which makes that add of remotes look positively sane in comparison. Or you can use the BFG repo cleaner, which is a happy little tool. Sorry. Happy little tool that you can just Google. My buddy Roberto Tiley has created it. You can click there, and he's got very detailed instructions on how you can, actually convert an existing repository to use LFS. And as he notes, it's an alternative to filter branch because filter branch is scary. One of the first things it supports is removing crazy big files. So top tip, use BFG repo cleaner. Okay. Go ahead and close that. Wonderful. Let me switch back here. Cool. So another top tip is to use the latest version of Git, especially if you're on Windows. This is especially true for Git for Windows. Why should you use the latest version of Git? Well, Git is very responsive to security advisories. And I regret to tell you that there are, in fact, security holes in Git from time to time. And they are, I don't know, a little scary. I don't want to oversell them, but I also don't want to downplay them. The idea that you could run git clone on a repository and have remote code execution actually running code that gets shipped in that repository seems a little scary. I mean, you expect that to happen if you actually build the code and run the code, but you don't expect that if all you do is run git clone. So it's important to stay up to date with security advisories. The other thing that is nice about making sure that you're up to date with Git is that Git is aggressively pursuing performance improvements. And when it comes to the Git project as a whole, a lot of these are being done for the sake of very large repositories. In fact, this is something that we've been investing in at Microsoft, is improving the performance for large repositories like Windows. Windows is the largest Git repository on the planet. It's about 350 gigabytes. That is absolutely madness. And so we have to continue to make performance improvements to try to make Windows faster and more secure. But even if you're using smaller repositories, then Git for Windows is working on performance independently. The idea is that, well, there's really no two ways about it. Git was built to manage the Linux kernel. It was built by a guy named Linus Torvalds to manage the development of the Linux kernel. And so Git is very tuned to work on Linux. So it's built in the philosophy of being a Unix app, where it's actually multiple little utilities that are run. So when you run git clone, git space clone, what Git actually does is it goes and finds an application called git dash clone, which, okay, that's fine. So it's not one big app, it's multiple little apps, that's fine. But what each of these applications does is then talks to each other. And since it's not all one big app, that means that they're calling exec. And that's fine. That's very, very much in the Unix philosophy. The other thing that happens is that sometimes they're shell scripts. Have you ever wondered why Git for Windows is so big just to be a version control system, and why it comes with this weird thing called git bash? Well, it comes with git bash because so many of the tools in Git are shell scripts that it actually needs bash to be able to run them. The other thing about git bash, or rather the shell scripts in bash, is that they run things like sed and awk and cut and all these crazy three-letter Git command, Unix commands. And it does that because that's just the way Unix systems work. But Unix systems don't really scale the same way as Windows systems. Unix is really good at being able to exec programs over and over again. Windows, not so much. Windows is good at creating threads from an existing application, and it's a bit slower at actually creating creating new processes. And so you see that. When you run git rebase, rebase is one of the worst offenders. If you run git rebase on Windows, you see it working, you feel it working. When you run git rebase on Windows, on Unix rather, it just goes. And so a lot of the improvements in Git for Windows are coming in that area where we're rewriting things like rebase and like stash in C instead of shell scripts. And it sounds like that wouldn't be such a big improvement, but oh, it truly is. So the newest version of Git for Windows, 2.19, actually has this on as an option. But what I want to do is just give you a quick example of why this is so important. This is the easiest C program ever. Return 0. Does nothing, right? It's called noop.c. And then I've got another program that's a little simpler here called exec.c. All this is going to do is call noop.exe, which is we're about to build it right now. And it's going to run it 1,000 times. And this is actually a pretty realistic example of the amount of time. If you ran git rebase with 1,000 commits, I hope you don't, or probably even 100 commits, which I also hope you don't, you could end up execing 1,000 processes. I think that's very realistic. Okay. So if we go into that directory now, okay, and let's start it up. Exec.exe. Okay, we're just going to run noop a bunch. Meanwhile, let's flip over to a Unix system where I've got the exact same thing. noop.c, return 0. Exec.c, runs it in a loop 1,000 times. Great. And we're done. Meanwhile, let's flip back over to Windows. Still running. And this isn't to shame Windows, this is just an architectural decision. Starting new processes is heavy on Windows. Starting threads is lightweight. Starting new processes on Unix is lightweight because it has to be. And if you don't believe me that it actually did anything, let's put a hello world printf in there and make sure to compile it with optimization and ignore the warnings and run exec again. Yeah, it's actually doing something. So it's running 1,000 times and Windows still isn't done. So you can see how this sort of naive translation of Git from a mix of C and Bash, and it's got some other languages in there too, like Perl and Python, into the Windows experience is not ideal. And so the Git for Windows team is aggressively pursuing these improvements so that they can bring you better performance. Okay. So, I mentioned earlier that a top tip is what's called trunk-based development. I don't encourage you to, I'm sorry, I gotta Control-C this because my laptop's about to melt. Trunk-based development. I don't encourage you to use something like Git Flow where you have a dev branch and a master branch. I encourage you to just have a single master branch and create topic branches based on that. So back in the old days when we were basically using TFVC, at least around Microsoft, we would encourage people to create these very complex branching strategies. We even had a document called the ALM Rangers Branching Guidance, I think it was called. And it was a dense document, and it documented the way we did branching at Microsoft. And what it really did was it documented the organizational structure of Microsoft, or at least of my team. You may have heard of something called Conway's Law. Conway's Law says that we build systems that reflect our org chart. We ship the org chart, it's sometimes known. And that's true of branching as well, at least in the old days of the branching guidance that we used to have. We used to say that organizations tend to produce branching structures that copy the org chart. And that was very true within my team at Microsoft. We actually shared a repository with Visual Studio itself. the VSTS team did. And we would each have a branch. We would branch off trunk. The VS team would have a branch, we would have a branch. And then we would have sub-branches based on our place in the organization. I was in the VC branch, and I would usually create a branch from that to do my work, to isolate it. And boy, that gets heavy and complicated when it comes to merging. So I would merge all my code down, and eventually it would land in the main branch, and then it would all get integrated together, and then it would all get merged back up, and oof, we called it merge hell. It was not good. So we recommend something so much simpler. Our lives are so much easier on a day-to-day basis because we use a trunk-based branching structure. That's our branch. There's one. It's called master. That's it. When we go to do work, we do exactly what I did earlier on tip number 1, which is pull requests. We create a topic branch, whether that's a bug fix, whether that's a feature, and we merge it. Sometimes, very rarely, conflict sneaks in, and then we will merge master into our topic branch, and then we can merge it into master. It's very simple. It's very peaceful. We have a lot of branches going on at once, which is not complicated. There is no merge hell here because these are so short-lived. I'm talking hours, potentially, minutes, days at most. The idea is to make sure that we get code into master as quickly as possible. How do we avoid shipping code that we're not ready to ship? We use feature flags. We use feature flags aggressively on the Azure DevOps team. There's always code that isn't ready to go into production. There's always code that users aren't supposed to see. We, in fact, changed the whole name and look and feel of Visual Studio Team Services, split it up into several different products, and we did that all with feature flags. So I had Azure DevOps a month ago. You were still using Visual Studio Team Services. So that's how we do the isolation. Instead of having branches for isolation, we use feature flags for isolation. And the goal is to make sure that we have few conflicts and that our code is always able to be compiled at all times. We take that a little bit further at Microsoft. So some people will call this GitHub flow, which is not quite accurate. If you actually go and read the GitHub flow document, notice GitHub flow, like GitHub the company, not Git flow, like the one I was complaining about earlier. GitHub flow basically describes this. However, there's a wrinkle in there in that document that they describe that is often lost. They actually ship each of these pull requests to production. And they don't ship it to production after it's merged into master. This is their trial. When you open a pull request at GitHub, you get code review from all of your peers. It'll kick off a continuous integration build, all of the things I talked about earlier. And then, when you're ready to merge it, you don't click merge into master. You deploy that branch to production, which is terrifying because the opposite is also true. If you were to just click merge without actually doing that deploy to production, the system would notice that that hadn't happened, that the deployment hadn't happened, and deploy it. So your first day at GitHub, when you're not used to this and you click merge pull request, you'll do a deploy to production. Ask me how I know. Once you've calmed down a little bit from that, you start to understand the process. The idea there is that there is no better test than actually living in production. So they'll do a canary deploy and a very gradual deployment to make sure that your code is good and that it also doesn't affect too many people. And I think that this is a great tip. I didn't make it a top tip, but I think it's a great strategy. So if you are small enough that you can deploy to production with that sort of velocity, I think GitHub Flow is amazing. So go back and read GitHub Flow. And if you're in the DevOps-y kind of agile-y place where you can make that work, you might want to think about it. We're not on the Azure DevOps team. We are too big. And in fact, when I left GitHub, they were kind of too big too. They had too many servers, they had too much code, too many services. Deploying to production took a while. And so they would get into these places where everybody would have pull requests open, and if you were in the US and you were ready to actually merge your code, you would start to deploy your pull request. You would actually get in the deployment queue. GitHub uses Hubot, so you would sit in a chat room and you would type, queue me to deploy this branch. And Hubot would come back and say, okay, great, you're 8th in line. And you're like, oh, if each deploy, let's see. If a deployment takes a few minutes, and then you want to have a few minutes in the canary to make sure everything's good, and then you need to deploy to the rest of the machines, and that'll take a few minutes, times 8 means I'm just going to go home. This actually happened. I was fortunate that I live in England, so I'm time zone offset from San Francisco, which made me a little bit happier. So Azure DevOps has the same problem, except that we're bigger, right? We have more services than GitHub does, and we have more machines, and they're spread out over more geographic places. So we don't actually do GitHub flow. We do what we call release flow, which is trunk-based branching, like I mentioned. You open a topic branch, open a pull request, get it code reviewed, get it merged into master, and then we deploy every sprint. A sprint for us is 3 weeks. So we deploy new features every 3 weeks. When it's time to deploy, that's when we create a new branch. And I wish we didn't have another layer of branches, but we do, and for good reason. We create a new branch and deploy that branch to production. So when milestone number 120, that's what we call our sprints, ended, we created a branch called M120. We call it a release branch. It releases M120. And we deploy that to production. When we are done with that, when it's time to release M121, we throw that branch away and we create M121 and we deploy that to production. We could get away with just a release branch in a perfect world where we didn't have so many data centers because we do ringed deployments. They can take a little while. We actually want to have both M120 and M121 alive at the same time because our ring 0 is going to have M121 immediately. But ring 4, because we do these stage deployments, won't. So it's not impossible, and it does happen, that we need to hotfix a bug in production, and we actually have to target both M120 and M121. What does a hotfix look like for us? Well, let's say that topic branch there, the furthest right one on the bottom, let's say that's a hotfix. Let's say that's a critical thing that needs to get into production immediately. It can't possibly wait. It needs to get there as fast as we can. What do? We branch it off of master and merge it into master first. What? That sounds crazy. Why are we taking that extra time? Why is this going into master? Master doesn't get deployed to production. M120 is in production, M121 is in production, whichever. Master is never in production. Why are we doing this? This is crazy. We always make the change against master first. And the reason for that is that once upon a time, we created a hotfix branch off of the release branch, in this case, M121. And we fixed the problem, we merged the problem, we deployed the fix, and then we forgot about it. We never merged that fix into master. So we eventually did a new deploy and had the same problem all over again. Sorry about that. This was a long time ago. We've learned a lot of these lessons since then. So now what we do is we create the merge against, we create the pull request, we create the branch against the master branch so that we will never regress these bugs. And once that's in master, then we cherry pick it. We cherry pick the pull request into the other branch. And we actually have functionality in Azure DevOps and Azure repos to cherry pick an entire pull request right from the web UI. So if I go to my pull requests, why don't I go ahead and complete this nice pull request here against master. So I'll approve it, complete it, great. Now that is in master. As soon as I do that, you'll notice these funny buttons right here. Maybe you've seen these and never known what they do or why they are there. Why on earth would you cherry pick a pull request? It's for the release flow workflow. So I can take this code that landed in master and I can cherry pick it onto a new branch. And so this is exactly what we do with our branching structure. So when we have a hotfix, we merge it into master, then we click cherry pick, and we'll get a new pull request against our release branch. Now, of course, I say always, but it's not always. Rules are made to be broken. Sometimes you've already fixed a bug in master. You didn't realize it would cause some outage, and whoops, it has. No, that's a bad example. We'd still go back and cherry pick that pull request. Sometimes you've just refactored code away, I guess, in master. And meanwhile, that same code has caused a live site incident. That's what we call our outages on the Azure DevOps team. And so you just have to go and code it manually against the release branch. There's nothing explicitly wrong with that. It's just that we want to avoid it to avoid regressions. Right, cool. All right, let me hop back over. Great, all right, there's the button I need. Thank you so much. It's been a long 75 minutes. Thank you for letting me dive in to a little bit of the guts of Git and a little bit of using VI. If you have questions, I'm happy to stick around and answer them. And of course, remember to evaluate. So thanks so much.